Introduction of GM tube. The GM counter is an instrument used for the measuring ionizing radiation. It detects the ionizing radiation such as alpha particles, beta particles, and gamma rays using the ionization effect which produce in a GM tube. It is perhaps one of the world's best known radiation detection instruments. Working. When an energetic charged particle enters a GM tube through the window, the gas molecules which interact with the charged particle get ionized. The generated electrons get accelerated towards the central anode and the positive ions towards the cathode. The accelerated electrons cause ionization of more gas molecules, which generating a large number of electrons within a very short interval of time, which called as avalanche. The avalanche gives rise to the high current pulse. And for each particle which entering in the tube, successive current pulses are produced and counting is done by a suitable device. Aim: to plot the characteristics of Geiger-Muller tube and determine its operating voltage. Geiger-Muller counter, popularly known as GM counter, and is the most popular device related with the radioactivity. When the voltage applied to a gas field detector is increased beyond the proportional counter region, the pulse height does not remain proportional to the energy of charged particles. The counter, which operates in its region of higher voltage, is known as GM counter. Let us look towards construction. The GM tube consists of drug metal case enclosed in a thin glass tube. The hollow metal case acts as a cathode. The fine tungsten wire turns through the center of the tube and is insulated from the metal. It acts as an anode. The tube is evacuated and then partially filled with a mixture of 90% argon at a 10 cm pressure and 10% ethyl alcohol vapor pressure at 1 cm pressure. At one end of the tube, a thin window of mica is arranged to allow the radiation into the tube. Let us look towards the GM counting system. Here, we set a range of voltage up to 310 as we are using the beta source CS137. We are setting here the time of 30 seconds by varying the program. Let us move towards the procedure. Here, we are using beta source to plot the characteristics of GM tube and to determine its operating voltage. The question arises here that why we are using beta source. At first, it is easy to handle as comparison with alpha source and can be easily available. And the main cause for using the beta source is alpha source is more hazardous than beta, and if in contact with body, it causes skin diseases as well as cancer. In order to obtain the counts, we set up the operating voltage at 340 volts and the time for 30 seconds. As here we are using the beta source CS137. Now insert the beta source 137 in the third window of GM tube, and for counting the counts, click on the start button. As the time varies, we can able to see the counting variations in the GM tube, which displays at 340 volt. We can see here at the time of 30 seconds, we get the count 1028. Now, in order to obtain the background counts, we have to remove the slide owning the CS137 and keep it as far as possible from the GM tube in order to avoid the radiation. Now place the same slide in the third window of GM tube and record the readings for the high voltage of 340 and the time limit of 30 seconds. Whatever the count we will get, this count is known as background count. Here we are getting the background count 7. Plateau curve of the GM counter. Number of particles count per second is called as counting rate, that is CR of GM counter. The graphical representation of variation CR with variation in potential difference V between the anode and the cathode of a tube is called as plateau curve of GM counter. The potential at which the pulses begin to appear is called as threshold voltage, VTH, of a GM counter. For V is less than VTH, the number of electrons reacting the anode is so small that electric pulse cannot be detected. The portion of a plateau curve, that is V1 to V2, within which the CR remains almost unchanged, is called as Geiger-Muller region, and the formula given as below.